If you're a developer working with user location data, you know you're sitting on a gold mine. But it's also a landmine, right? In the next few minutes, we're going to break down how to handle that data responsibly, so you can build all those amazing features without the massive privacy headaches.
Hey everyone, welcome to Call the API. Today, we're jumping right into the practical steps, the real-world stuff you can use to build incredible location-aware features, but without creating a total privacy nightmare for your users.
So, at the heart of all this is this fundamental tension. It's a real tug-of-war. On one side, location data is pure gold for app utility. It powers everything. Personalization, those cool location-based services, powerful analytics. But on the other side, it's probably one of the most sensitive pieces of user data there is. We're talking serious risks of re-identification, even safety concerns if that data gets into the wrong hands. Our job as devs is to find that perfect balance.
And to get there, we've got a pretty clear roadmap. First, we're going to decode what those latitude and longitude decimals actually mean in the real world. Then, we'll dive into our two main strategies, adding a little noise and the power of grouping data together. We'll wrap things up by finding a safe harbor with some clear, actionable rules you can use. And finally, we'll take a quick peek at what's next in this space.
All right, let's start at the very foundation. Before we can even think about protecting location data, we have to understand the incredible power that's packed into a single coordinate. It's kind of mind-blowing.
The key concept here is precision, and it's not about accuracy, whether the point is correct. It's about how granular our measurement is. The number of decimal places in your lat-long data translates directly to a real-world scale, and that's exactly where the privacy story really begins.
Let's just break this down for a second. With 0 decimal places, you pretty much know the user's general state or country. We're talking a massive 111-kilometer area. Add just 1 decimal place, and boom, you've narrowed it down to a specific city. A second decimal place? Now you're in a specific village or neighborhood about a 1.1-kilometer block. So far, so good, right? Seems pretty anonymous.
But this is where things get really sensitive. A third decimal place pinpoints a specific large field or a college campus. The fourth gets you down to a single parcel of land. The fifth can literally distinguish one tree from another. And the sixth, well, at 11 centimeters, you can do detailed construction planning. When your data has this much precision, you're not just tracking a user, you're tracking a person.
So if that insane precision is the risk, our first line of defense has to be strategically reducing it. So how do we fight precision with, well, a little imprecision? Let's get into our first set of tools, the art of obfuscation.
Obfuscation sounds fancy, but it's a really simple idea. We are purposefully making the data fuzzy. We take an exact coordinate and we intentionally alter it, adding just enough randomness to protect the individual's identity while, and this is the key part, hopefully keeping the data useful for broader analysis.
And you know what's great? This can be incredibly simple to implement. This is a real-world spreadsheet formula a developer used to start obfuscating coordinates. It just takes the original point, randomly decides whether to add or subtract a value, and then applies a tiny random number. It's a really basic but surprisingly effective way to just nudge a point enough to protect a person's exact spot.
Now, if you take that idea a step further, you get to techniques like geomasking. This is way more sophisticated. It basically moves a point within a defined donut shape, so not too close to the original spot, but not too far away either. This is awesome because it preserves the general spatial patterns in your data, which is great for analysis, but it makes it pretty much impossible to reverse engineer the original location.
And then you've got the big one, differential privacy. This is a formal mathematical framework that gives you a provable guarantee of privacy. It essentially makes sure that by looking at the final data set, you can't even tell if any single person's data was included in the first place. This is the gold standard, used by huge organizations like the US Census Bureau to release public data safely.
But hang on, what if you don't even care about individual data points at all? That brings us to our second major strategy. Instead of making individual points fuzzy, we just get rid of them completely and find safety in numbers by grouping them together.
And for this, we have a fantastic toolbox. You can use heat maps to show density, you can use grid systems like hexbins to just count events in an area without ever showing a single location. You can even merge geometries, like whole zip codes, or, and this is a crucial one, suppress small cells, which just means hiding any group that's too small to be truly anonymous. The goal is always the same. Shift the focus from where is this person to what is the pattern in this area.
And look at this transformation. On the left,
you've got a map that is a straight-up privacy liability. Every one of those dots is a potential person. But on the right, you have a safe analytical tool. It tells you the exact same story about where activity is concentrated, but it does it without exposing a single individual. It's a total win-win.
Okay, so now we have tools for both obfuscation and aggregation. But what are the rules of the road? How do you know when your data is private enough to build that user trust and, satisfy the regulators?
Thankfully, we don't have to guess. Organizations like the Network Advertising Initiative, the NAI, have created a really practical framework for us developers. They've laid out super clear guidance on what qualifies as imprecise location data, data that's considered safe enough that it doesn't need the strictest user consent.
And they offer 3 beautifully simple paths to get into this privacy safe harbor. First, if you're using place names, stick to generic ones. Starbucks is fine, mom and pop's hardware is way too specific. Second, if you use geofences, make them big, over 800,000 square meters. We're talking a whole neighborhood, not a single storefront. And third, the one that really brings this all home for us.
Round your coordinates. Yep. According to the NAI, a GPS coordinate with 2 or fewer decimal places is officially considered imprecise. This is your safe zone. Storing 40.71, -74.00 puts your in a neighborhood-sized block. It gives you valuable city-level data without exposing an individual. This is such a powerful, definitive, and actionable rule you can literally go and implement today.
Whew, we have covered a lot of ground, right? From the power of a single decimal point all the way to industry-standard rules. Let's bring it all home with one final, actionable takeaway.
Here it is. This is your privacy toolbox. 3 core strategies you can use depending on what you need. The absolute simplest and honestly often the most effective is just rounding to reduce precision. If you absolutely have to keep individual points, you can add noise through obfuscation. And if you're really just focused on the big picture patterns, you can use grouping and aggregation. Master these, and you are well on your way to being a responsible data steward.
But I am going to leave you with this one final thought. The techniques we talked about, they are today's best practices. But as AI gets terrifyingly good at re-identifying people by connecting all these disparate, so-called anonymized datasets, the goalposts are constantly moving. So the real question for all of us is, what does truly private location data even mean in the world of tomorrow? That's a challenge we're all going to have to solve together. Thanks for tuning in.